Hello everyone, welcome to your lecture on communications and network. And in this lecture, we shall discuss connectivity, the wireless revolution, and communications systems. Moreover, we'll describe physical and wireless communication channels. Furthermore, we'll discuss connection devices and services, including dial-up, DSL, cable, satellite, and cellular. Henceforth, describe data transmission factors, including bandwidths and protocols. To elaborate more on the learning outcomes, we should also look at discussing networks and key network terminologies, including network interface cards and network operating systems. We'll describe different types of networks, including local, home, wireless, personal, metropolitan, and wide area networks. We should also describe the network architectures, including topologies and strategies. And finally, we will describe the organizational issues related to internet technologies and network security. Introduction. With the advances in communications technology, the world is moving toward a connected society. Changes in network speed, improvements in accessibility, the pervasiveness of online communications mean that people can access information and services around the clock. This enables new approaches in education, healthcare, transportation, energy, and entertainment. In this series, we address the policy, the legal, and the regulatory aspects of the connected society through the use of computers. A connected society allows increased connectivity, potentially means increased productivity, especially in terms of business. Communication means the sending and receiving of information such as phone lines or computers. Computer communication is the process of sharing data and programs and information between two or more computers. Numerous applications depend on communication systems, including email. Emails are messages distributed by electronic means from one computer user to another or more recipients via a network. Instant messaging. Instant messaging, often shortened to IM or IMing, is the exchange of near real-time messages through a standalone application or embedded software. Internet telephone. Internet telephony refers to all types of telephony services, including phone calls, fax, voicemail, video calls, and other forms of communication where calls and data are sent digitally over the internet using internet protocol rather than being transmitted over traditional analog landlines. Electronic commerce. Electronic commerce is the buying and selling of goods and services or the transmitting of funds or data over an electronic network, primarily through the use of the internet. Global positioning systems, or GPS. Originally, Navstar GPS, it is a satellite-based radio navigation system owned by the United States government and operated by the United States Space Force. It is one of the global navigation systems, satellite systems that provides geolocation and time information to a GPS receiver anywhere on or near the Earth where there is an unobstructed line of sight to 4 or more GPS satellites. Connectivity is a concept relating to using computer networks to link people and resources. Microcomputers, mini-computers, and mainframe computers can all be connected. Wireless revolution. Wireless revolution is a use of mobile or wireless devices. The revolution is the support of more than just the wireless telephone. Many devices can and will connect to one another without any physical connection. Communication system continued. Electronic systems that transmit data from one location to the other. Communication systems can be divided into wired or wireless. The basic elements of electronic communication include four basic elements: sending and receiving devices, computers or specialized communication devices, communication channel, that is the message carrier. Communication devices act as an interface between sending and receiving devices, convert outgoing messages into packets that can travel across the communication channel. Data transmission specifications, rules, and procedures that coordinate the sending and receiving devices. Communication channels are essential to a communication system. They carry data. Communication channels carry the data from one computer to another. Two categories of communication channels include physical and wireless connection. The types of channels include telephone lines, coaxial cables, fiber optic cables, infrared, broadcast radio, microwave, and satellite. Physical connections. Physical connections normally consist of cables. The three major types of cables in a telecommunication networks are: Ethernet cable, consists of twisted pair cable, slowest being phased out by more advanced and reliable media. Coaxial cable, single solid copper core, 80 times transmission of twisted pair, usually used in television and computer networks. Fiber optic cable, 26,000 times capacity of wired twisted pair, more secure and reliable, best over limited distances, lighter, more reliable, and less expensive than coaxial cable. Wireless connections. Wireless connections do not use a solid substance to connect, uses the air itself. Types of wireless connections are radio frequency, microwave, satellite, and infrared. Let's discuss more into this. Radio frequency is the oscillation rate of an alternating electronic current or voltage or of a magnetic, electronic, or electromagnetic field or mechanical system in the frequency range from around 20 kilohertz to around 300 gigahertz. Wi-Fi comes under radio frequency. Bluetooth and WiMAX also come under radio frequency. Let's talk about Wi-Fi. Wi-Fi is a family of wireless network protocols based on the IEEE 802.11 family of standards, which are commonly used for local area networking of devices and internet access, allowing nearby digital devices to exchange data by radio waves. Bluetooth is a short-range wireless technology standard that is used for exchanging data between fixed and mobile devices over short distances. WiMAX, in long and in full, is worldwide interoperability for microwave access, is a telecommunication technology aimed at providing wireless data over long distances in a variety of ways, from point-to-point links to full mobile cellular type access. Infrared, light waves used over short distances, sometimes called line-of-sight communications. Sending and receiving devices must be clear view of one another. Broadcast radio. A broadcast radio uses towers called transceivers, web-enabled devices follow a standard known as Wi-Fi. Microwave uses high-frequency waves, also line of sight, used for short distances. And finally, satellites. Satellites communication uses satellites orbiting about 22,000 miles above the Earth as microwave relay stations. Many of these offered by Intelsat, the International Telecommunications Satellite Consortium, which is owned by 114 governments and forms a worldwide communications system. Satellites can be used to send and receive data. Uplink is sending data to satellite, and downlink refers to receiving data from a satellite. Satellite basically allows GPS communication. GPS stands for Global Positioning System. It uses a network of around 24 satellites owned and managed by the Defense Department of the United States, which continuously sends location information to Earth. The illustration in the slide shows a summary of communication channels. So some of these channels include twisted pair, coaxial cable, fiber optic, radio frequency, microwave, satellite, and infrared. All these have been broadly discussed in the previous slide. Connection device signals. There are two types of signals, analog and digital. Analog signals are telephone signals, and they come in terms of continuous electronic wave. Digital signals are computer signals, that is absence or presence of electronic pulses, either on or off signals. Connection devices. Types of modems. The long term for the term modem is modulator, demodulator. Modulator or modulation is the name of the process for converting from digital to analog. Demodulation is the name of the process from converting analog to digital. Telephone can either be internal or external, connects computers directly to a telephone line. DSL uses standard phone lines, external, and uses either USB or Ethernet. Cable modem uses coaxial cable, same as your television, uses either USB or Ethernet. Wireless modem does not use cables, also known as wireless WAN, that is wireless wide area network. Signals are sent through air. Transfer rate or transfer speed is measured in bits per second. The higher the speed, the faster the transfer rate. Connection services. Standard telephone lines and conventional modems use a dial-up service. It is slow, still popular, but many are using other types of connections. T1, T2, T3, and T4 lease lines do not require conventional modems and provide very high capacity and is expensive, mainly used by corporations not typical end user. T1 lines provide a speed of 1.5 megabits per second, which is over 26 times as fast as a conventional modem. DSL uses existing telephone lines to provide high-speed connections, uses DSL modem. Cable connections reach 90% of homes in America, but not all cable companies support cable modems presently. Satellite or air connection services uses just what it says, satellite and air connections. Older satellites couldn't upload and dial up and were still using for the process. But newer satellites are two-way satellites capable of handling both uploading and downloading, available almost anywhere but slower than DSL. Cellular services option for mobile devices and laptops using 3G and 4G cellular networks. Current access is limited but growing. Download speed to 400 to 700 kilobits per second and upload at 50 kilobits per second. Future services will have speeds equal to or greater than DSL. Typical user connection costs, bandwidth, and speeds in comparable time required to downloading an image. In DSL, the maximum speed available is 1.5 megabits per second and will take about 1.5 seconds at a cost of $30 per monthly fee. Cable connection will allow a speed of 8 megabits per second with a time of 0.32 seconds at the rate of $40 per month. Satellite connection will allow 900 kilobits per second with a time limit of 2.8 seconds and a monthly fee of $75. Cellular connections will have the speed of 768 kilobits per second with a time of 3.2 seconds and at the cost of $55 per month. Data transmission. Data transmission is the transfer of data from one digital device to another. This transfer occurs via point-to-point data streams or channels. Several factors affect how data is transmitted. They include speed or bandwidth, serial or parallel transmissions, direction of data flow, and modes of transmitting data and protocols. Let's have a look at these factors more broadly in the next few slides. Bandwidth. Bandwidth is the maximum amount of data transmitted over an internet connection in a given amount of time. Bandwidth is often mistaken for internet speed when it's actually the volume of information that can be sent over a connection in a measured amount of time calculated in megabits per second. Measurement of the width or capacity of the communication channel. Several technical matters affect data communication. One is bandwidth, bits per second transmission capability of a channel. There are three types or three categories. First one is voice band, also known as low bandwidth. Standard phone line, too slow for many types of transmission, especially high quality videos. Typical speeds are 56 to 96 kilobits per second. Medium band, with special lease lines to connect mini computers and mainframes, as well as to transmit data over long distances for larger computer systems, not typically used by individuals. Broadband is used for high capacity transmission through DSL, cables, satellite connections. Specialized high-speed devices effectively transmit higher quality video and other communication needs, typically 1.5 megabits per second, and higher speeds are possible. Baseband, widely used to connect individual computers that are located close to one another. Serial and parallel transmission. In serial transmission, bits flow in a series or continuous stream like cars crossing a one-way lane bridge. With parallel transmission, bits flow through separate lines simultaneously. In other words, they resemble cars moving together at the same speed on a multi-lane freeway. In serial transmission, a single link that is used to transmit data bits and only one bit is transferred at a time. In parallel transmission, data bits are transmitted simultaneously through multiple links which are placed parallel to each other. Direction of data transmission. Data transmission takes place in three modes. Simplex communication resembles the movement of cars on a one-way street. Data travels in one direction only. It is not frequently used in data communication systems today. One instance in which it is used may be point of sale terminals in which data is being entered only. In half-duplex communication, data travels in both directions but not simultaneously. That is, data flows in one direction at a time. This resembles traffic on a one-lane bridge. In full duplex communication, data is transmitted back and forth at the same time, like traffic on a two-way street. Therefore, data travels back and forth simultaneously. It is clearly the fastest and most efficient form of two-way communication. The illustration in the slide shows a demo of three modes of data transmission. Simplex, where data flows in one direction only. Half duplex, whereby data flows in both directions, but not simultaneously. Full duplex is whereby data transmits in both directions simultaneously. Modes of data transmission. In asynchronous transmission, the method frequently used with microcomputers, data is sent and received one byte at a time. Asynchronous transmission is often used for terminals with slow speeds. Its advantage is that data can be transmitted whenever convenient for the sender. Its disadvantage is a relatively slow rate of data transfer. In synchronous transmission is used to transfer great quantities of information by sending several bytes or a block at a time. For the data transmission to occur, the sending and receiving of the blocks of the bytes must occur at carefully timed intervals. Thus, the system requires a synchronized clock. Its advantage is that data can be sent very quickly. Its disadvantage is that the cost of the required equipment is generally high. Rules for exchanging data between computers are known as protocols. Essential features of protocols include TCP/IP. TCP/IP is the Internet Protocol Suite, which has a set of communication protocols used in the Internet and similar computer networks. TCP/IP has two components: identification, identifying sending and receiving devices, the IP addresses. The Internet unique number address is generally the IP address. The domain name server converts text-based addresses to IP addresses. Packetization. Packetization allows messages to be broken into so easier to transmit over Internet through various interconnected networks, allows message to be reassembled at the destination. Communication protocols continued. A packet is a parcel of data that is sent across a computer network. Each packet contains the address of its sender, the destination address, and a sequence of numbers with some data. Second switch technology, the one that is available on the top right of the slide, is a telephone system, generally inefficient. Packet switch technology, one available at the bottom right, is an efficient communication system. Communication protocols continued. Every packet that travels over a network includes the addresses of its destination device. Two commonly used addresses are MAC and IP addresses. A MAC address is a unique number assigned to a network interface card when it is manufactured. Can be employed to establish network security. An IP address is a series of numbers used to identify a network device, assigned to network computers, servers, peripherals, and devices by ISPs or system managers. Example, 204.127.129.1 is an IP address, and it is generally divided into 4 sections called octets. IP addresses can also be obtained through the DHCP protocol, which is Dynamic Host Configuration Protocol. Networks. A computer network is a communication system that connects 2 or more computers so that they can exchange information and share resources. A node is any device connected to a network. A client is a node that requests and uses resources available from other nodes. A server is a node that shares resources with other nodes. Dedicated servers specialize in performing specific tasks. Could be an example of an application server, communication server, database server, file server, printer server, or even a web server. Directory server, a specialized server that manages resources such as user accounts for an entire network. Host is a large centralized computer. Switch, the center or central node for other nodes, previously done by something called a hub. Network interface card, or NIC, connects the computer to a network. Network operating system, NOS, software to control and coordinate activities between computers on a network. Network administrator, a computer specialist or a network administrator. Communication networks differ in geographical size. 3 important types are LANs, WANs, and MANs. Let's look at LANs. In LANs, computers and devices link in close proximity to each other, linked by cable, typically use a bus form of organization. With gateways, LAN can be connected to other LANs or any other type of network. Ethernet is one standard for connecting networking nodes together. Home networks. LANs are now being commonly used by individuals in home or apartments, allow different computers to share resources, including a common internet connection, can be connected by various means, including a wireless LAN that uses radio frequencies to connect computers. All communications pass through the network's centrally located wireless receiver. Home networking includes the following: radio frequency, telephone lines, electric wiring, cables, network interface cards, or adapter cards. Wireless LAN. Wireless LAN is basically the short for wireless local area network. All communications pass through the network's centrally located wireless access point. PAN, or personal area networks, works within a very small area, connects cell phones to headsets, PDAs to other PDAs, keyboards to cell phones, etc. Metropolitan area networks, or MEN, also known as a regional network, span distances up to 100 miles. Network linking nodes and resources within the geographical bounds of a city. Cellular phones can extend and reach of a MEN. Wide area network, or WAN, countrywide and worldwide networks use microwave relays and satellites to reach users. Internet is the widest WAN. Network architecture. Networks are connections of two or more computers that work together to exchange information and share resources. The network architecture describes how the network is arranged and how resources are coordinated and shared. Network architecture also describes how a computer network is configured and what strategies are used. A network topology is a network arrangement or configuration of computers. The types of network topology include bus, ring, star, tree, hybrid, and mesh, with bus and ring being legacy or old type of networks which has become obsolete, and star, tree, hybrid, and mesh used currently. Bus network. In a bus network, each device handles its own communication control. There is no host. Common connecting cable called a bus or a backbone is used. Not as efficient as star, but it is low cost and widely used. All communications travel along this bus. There is no host. Messages are passed device to device in a sequence. A ring network. Each device connected to two other devices forming a ring. No central file server or computer. Messages pass around ring until reach correct destination. Often used to link mainframes, especially over wide geographical areas. Useful in decentralized organizations. Makes possible distributed data processing system. Computers can perform processing tasks on their own, can also share programs, data, and other resources. Star network. A star network is most widely used network topology for both homes and large businesses. Each device connects directly to a central network switch. In a star network, nodes are connected to a single computer called the network hub. This is generally a switch. All communication passes through the switch. Each connecting device is asked whether it has a message to send, and then each device is in turn allowed to send its messages. Most widely used network topology today. Tree network, sometimes called a hierarchical network. The central node is connected to two or more subordinate nodes that in turn are turned to other subordinate nodes. Useful in centralized organizations. Hybrid network. Hybrid network is a combination of different topologies. Large organizations have complex network of smaller networks. These smaller networks use a variety of configurations. When connected together, they form a hybrid. Mesh network. A mesh network is a local area network topology in which the infrastructure nodes connect directly, dynamically, and non-hierarchically to as many other nodes as possible and cooperate with one another to efficiently route data to and from clients. Does not use a specific physical layout, but requires that each node have more than one connection to other nodes. Wireless technologies are frequently used. Network strategies. Every network has a way of coordinating the sharing of information and resources. There are 4 common strategies. Terminal server network. Processing power is centralized in one large computer. Client or server networks are computer networks that use a dedicated computer called a server to store data, manage or provide resources, and control user access. The server acts as a central point on the network upon which the other computers connect to. A computer that connects to the server is called a client. Peer-to-peer network, a group of computers that are linked together with equal permissions and responsibilities for processing data. Unlike traditional client-server networking, no device in a peer-to-peer network are designated solely to serve or to receive data. Distributed processing network. Distributed computing is basically the technique of linking together multiple computer servers over a network into a cluster to share data and to coordinate processing power. Organizational networks. Internet. Internet uses browsers, websites, and web pages like the public internet, typically include email, mailing lists, news groups, and FTP services. Internets basically are a private network within an organization. Works like the internet where employees use browsers to access websites and web pages. Extranets are private network that connects organizations. Works like the internet but provides suppliers and other trusted partners with limited access to the organization's network. The purpose of extranet is that it increases efficiency and reduces possible costs. Network security. Network security refers to the means and the methods of securing a network within an organization or for an organization. Firewalls. Organizational firewalls include a proxy server that is a gatekeeper. All communications between the outside world and an organization must pass through the proxy server where the source and the content of each communication is evaluated. End users have many of the same concerns regarding security as organizations and can use firewall as well. Intrusion detection systems use advanced pattern matching and heuristics, can recognize signs of a network attack and disable access before an intruder can do damage. Virtual private network creates a secure private connection between a remote user and an organization's internal network. It creates the equivalent of a dedicated line between a user's home or computer and a company server. Careers in IT. Let's have a look at the network administrator in today's lecture. A network administrator is an IT expert that manages companies' LAN and WAN networks. They maintain networking hardware and software and diagnose and repair problems that arise. Candidates usually have a bachelor's degree in computer science with relevant practical experience. Annual salary of a network administrator in the United States of America may range between $48,000 to $48,500 to $79,000. In Fiji, a network administrator salary may be between $25,000 to $50,000. A look to the future. Telepresence. It lets you be there without you actually being there. Seeks to create the illusion that you are actually at a remote location. Early implementations mainly focus on extensions of video conferencing. In the next few set of slides, you have some questions that can be answered by you or can be discussed within pairs or groups. To ensure that you go through these questions so that you get a proper understanding of today's lecture. Thank you for listening, everyone. Goodbye.